Hello and welcome to lesson 2.5, Sine Law Part 2. So recall that in any triangle ABC, we have this version of the sine law. And also recall that you can flip this upside down as well. So it could be A over sine A equals B over sine B equals C over sine C, or it could likewise be sine A over little a equals sine B over little b equals sine C over little c. That's just for the triangle that is labeled in this manner, ABC. Of course, it could be any letters there, replacing A and B and C. So let's jump into a couple of examples. In triangle ABC, you're given these measurements. Sketch and then solve the triangle ABC. The measure of the sides should always be accurate to one decimal place and the angles accurate to the nearest degree. So when you're sketching triangles, you could just draw a generic triangle ABC. But try and get it somewhat realistic, and then you can ask yourself if your answer seems realistic in turn. So my angle A is 25. That's really quite a small angle. So we'll start with angle A, maybe looking something like this. Okay. So we'll call this A and mark this up as 25 degrees, like so. All right, angle B is 77 and side B is 12.2 meters. So angle B being 77, maybe that would be suitable for this one. 77 degrees, would you say? And side B is 12.2 meters. We, of course, remember that the side takes the small letter of the large letter of the angle opposite. So that will do for a sketch, I think. Sketch and solve the triangle ABC. The measure of the sides, okay, fine. We've got to solve the triangle. So that means we're finding everything missing. So what we have missing is angle C. We have side length A and side length C. Well, let's start off with the easiest of all, which is angle C, because we know that angles in a triangle add up to 180 degrees. So we state that C is equal to 180 minus the two given angles of 25 and 77 degrees. And you can do this in your head or use a calculator like I'm doing to make sure you're accurate. 78 degrees is angle C. You can mark that up once you have it. Okay, now we have that information. We need to solve for side length A and side length C. To start by drawing a baby carrot around the two opposite values that we definitely do have, which would be B, angle B and side length B. So we'll use that in our calculations for sure. And then the first one I'm going to calculate is side length A. Okay, so starting with your unknown value, which is little a, divide that by sine of big A, 25 degrees, and set that equal to little b, which is 12.2, divided by sine B, which is sine of 77 degrees. Now, just as with any proportion, we solve it with a peanut method. So we end up with A is equal to 12.2 sine 25 degrees divided by sine 77 degrees. Now, hopefully you're following along with this and trying this out on your calculator, making sure it's in degree mode. And just type it in as you see it. And you should get that side length A is approximately 5.29 or 5.3 meters long. And because my diagram looks fairly accurate in terms of the angle sizes, I'm thinking that, yeah, if this is 12.2 meters, then sure enough, that certainly looks like it would realistically be 5.3 meters. So I'm pretty happy with that result. Okay, now for the next one, for side length C, we can again draw our little carrots around our known values, B and B. And this time we're going to use C and C, starting with the unknown. And the unknown in this case is little c. Divide that by sine of big C, 78 degrees, equals little b of 12.2 divided by sine of big B, 77 degrees. Again, use a peanut method to multiply those two together, leaving you with C equals 12.2 times sine of 78 and divide by what's left over. which is sine of 77. Again, in your calculator, just put it in, and it should give you 12.24, which rounds to 12.2. Don't forget the units, meters. And does that look realistic? Certainly does to me. And that is a triangle solved. I'd like you to highlight your answers when you do this on a quiz or a test so that I can immediately have my eyes on your final answers, which will give me a good indication that everything else is fine. Okay, let's do another one. In triangle RST, we have the following values: sketch and solve. So we start off with the angle. It's definitely easiest to do that with angle R. So I usually start off with a horizontal piece, and then angle R is 47 degrees. It's kind of like quite steep actually. Okay, so we'll label that up angle R, label it up with 47 degrees, and that's good. Then we have S and R. R is 78 and S is 106. Oh gosh, I don't know. Let's see. I'm just going to erase this bit a little bit here. Because I want to engineer it so that my side length R is, whoops, that didn't work. Side length R is 78 and side length S is 106. So, no, that's not going to work. See, I'm being challenged now with my drawings. Let's see, 47 degrees. This might not be a terribly accurate drawing, and that's okay. So we'll call this 78 centimeters, side length R. And S, we'll pick this one. So S, which is 106 centimeters. And the other letter is T. Okay. So now we need to solve it. Can we figure out the angles first? Probably not easily. We only have one given angle. So we need to use the other information that we have to be able to solve for another one of the angles. So we have this side length R and angle R that we have. And then the only other value we have is side length S. So we'll have to use that in order to figure out angle S. So starting out with the angles, if the angles are the ones that we are trying to find, you start off with sine law upside down. So sine of S, divide that by side length S, 106, equals sine of R, divided by side length R, which is 78. And in fact, I did write R, but I should be writing in the angle value of 47 degrees. Okay. Now multiply, cross multiply, giving you sine S equals 106 times sine 47 degrees, and divide that by what's left, 78. Put it into your calculator. You get the answer of sine S equaling 0.9939. Leave that value in your calculator and immediately press your shift button, then sine, then equals to get the inverse sine of it. And that should give you the value of 84 degrees when it's rounded. And well, my diagram wasn't too bad. It kind of looks sort of near 84. There you go. All right, so we've got that angle done. Now we can easily figure out angle T using the properties of angles in a triangle, adding to 180 degrees. So we'll subtract the 47 that we were given and the 84 that we just found. 180 minus 47 minus the 84. That gives me an angle T of 49 degrees. We can label that up too. And the only thing left now is to find the value for the side length T. So to do that, we will get rid of one of the carrots there. Oops. I somehow lost all my information there. I don't know why. Anyway, and we'll highlight these two. Again, T was 49 degrees. And S was 84 degrees. There. Okay. Okay. Let's find T. Starting out with T divided by sine of T, which is 49 degrees. Well, isn't that just strange how that just popped back up there? How bizarre. See if I can get rid of that extra right now. Oh gosh. Right. Don't know what went on with that then. Very strange. Okay. T over sine of 49 degrees is equal to 78, which is my R value, divided by sine of R, which is 47, sine 47. So T is simply equal to 78 times sine 49 degrees divided by sine of 47 degrees. And that gives you the answer of 80.5 centimeters. And that looks realistic. I'm happy with that. Okay. And that's really all there is to it. You have some assigned work to practice on. Practice makes perfect. And you just follow the steps that I've gone through. You shouldn't have any issues. Let me know if you do. All right. Take care. Bye bye.